Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at some code associated with a recent quiz that I gave. This video is part of a larger series of videos focusing on the fundamentals demo and the fundamentals of the C programming language, and assumes that you have watched some of the earlier videos on the arguments and switches and have obtained a copy of our instructions for our quiz, as well as the help snips file. So to begin with, let's take a look at the problem. The idea is that you want to build an executable that accepts some arguments from the command line and essentially controls the behavior of the executable. Now, I've kept the problem relatively straightforward. The idea is that you have a 2x2 grid where you simply want to update the color associated with each of the four elements in the grid: the top left-hand corner, the top right-hand corner, the bottom left-hand corner, and the bottom right-hand corner. And so the idea is that through a combination of switches, you can simply update the color. Now, our application should accept some switches such as a /H or even a /? To pull up the help for how to use your executable. Additionally, as these tier 1 switches are going to be referred to as, it should also support the ability to identify whether you are interested in the left or right side of the grid. And for your for your tier 2 switch, then you should also be able to handle the up or down. And so as a result, you should be able to ultimately handle left up, left down, right up, and right down. Now, if you include the /help and possibly optionally the /? Then you should have a total of 6 explicit switches that you have to handle in code. And so to appreciate this a little bit better, I have provided for you a table in PowerPoint. You can use Excel, or quite frankly, you can just use a pencil and a piece of paper to follow along. But the idea here is we want to see what all of those switch combinations would look like, including the argument 0 or the name of the executable itself. And so you can see here, I've done the first one for you. The executable is always going to be your 0th argument. You're going to have one argument there as far as the argument count. And then you want to provide for additionally a /H to get the help. Now, we're going to refer to this as an explicit call for help, meaning that the user intended to call your help. Now, continuing on with this, as I mentioned, we may also have the possibility of a /? being supported. The example here is also pretty straightforward. It would just simply be the name of the executable followed by the /? And we would argue that that would be another explicit call for help. Continuing on with this, we said that we want to support 2 tier 1 switches in addition to the help calls, and that is going to be either the left option or the right option. Now, at this point, you've got to decide which one of the tier 2 options you want to support, because left and right by themselves do not provide enough information. And so at this point, for each of the left tier 1 options, we want to have the option of having both up and down. And so as a result, we're going to have left up, left down, right up, and right down. So let's make a quick modification to give us some room. I'm going to go ahead and change this to /left as well. And then I'm going to add /right and /right. Now, for the tier 2 options, we want to have /up and /down. And in this case, you'll notice that you get a total of 3 arguments so far. And we'll come back to that in just a second. But continuing out this portion of the table, you have then right up, right down. Now, if you go back to the original instructions for the quiz, you'll note that I said that you have to specify an additional argument, and that is the color that you wish to provide. Now, I wasn't very picky on this. The idea is that you could just provide some sort of named color, so we'll keep this one fairly simple in that, let's say you want to convert the left up quadrant to red. Well, you simply provide red then as the fourth argument, or argv square brackets 3. We will do a green for the left bottom or left down. And then for the right up, then we'll do blue. And then for the right down, we'll do yellow. The key is that you have to provide that fourth argument. And so combining then all of these, what you should get for your command line arguments would be /left, /up, followed by the color that you wish to provide. For the left down, be /left, /down, followed by green. For the right up, it would simply be /right, /up, and in this case, blue. And then for the right down, /right, /down, and then yellow. The key to note is the total number of arguments here. So for this to work, in other words, for you to be able to correctly call one of the options, you have to provide a total of 4 arguments. Now, additionally, we also want to support the nonsense option, meaning that somebody provided something other than what we intended. And when I say nonsense, I don't mean that they explicitly typed in nonsense. It just means that it was something that was completely unusable or unrecognized with respect to our application. And so this could be anything. And the idea here is that these 4 cases are all going to be explicit. In other words, where they handle the left up and the color, left down and the color, right up and the color, and right down and the color. All of these are going to be explicit. And then in this particular case, this last one here where there's nonsense, it's going to be implicit, because essentially the user of your application didn't know what they were doing and just put something in. And in this particular case, what we want to once again have happen is to call the help. And so depending on whether you break the /h and the question mark up into 2 separate options, you'll either have a total of 5 or 6 explicit arguments to handle. In other words, things that we can identify and essentially triage appropriately. And then everything else, maybe, for instance, the incorrect number of arguments, as well as no arguments, can simply fall into the category of nonsense. And basically at that point, then those are implicit handling of arguments, meaning that in this case, we're probably going to call help. All right, so let's see this in code. Hopefully this visualization here was useful. And so let's see if we can convert this now into code. Now, as always, I encourage you at the top of your main, especially while you're learning the arguments and switches, to simply go ahead and set up a for loop that enumerates through each one of your arguments. And so to do that, we're going to start off with an index variable. And I'm going to have a couple of print statements here. First of all is just going to be the count of the number of arguments that we are passing to our executable. And remember that that stems directly from the argc input argument from our main. And then what we'll do is we will build using this index variable. We'll start at 0 and continue while the index is less than our argc. And then we will increment by 1 our index. And inside of this loop, what we're going to do is we're simply going to print out the argument itself. So it's going to be argv square brackets. And instead of hard coding a value in there, we're just going to use %d. And then make it look nice here, maybe a colon and %s followed by a new line. And the idea in that first placeholder, we will put the index. And in the second placeholder, we'll put whatever value that the user specified in the argument itself. So argv square brackets index will represent the value in that location in the argument array. Now, at this point, what we can do is we can go ahead and build it. And provided that you don't have any errors in your code, we should be able to run it. And so I'm going to go ahead and jump over to the command line. I'm going to go to the documents, my courses, in this case, E233, projects, and my QN switches folder. And just as a reminder, if we do dir, you'll see there's my dist folder, debug, and then min.gw. There is our QN switches executable. And if I just put something afterwards, you'll see there is the 0th argument is the name of the executable. And then argv square brackets 1 has something. And you'll notice they have a total count of 2. And if I put else after this, so space and then else, we get 3 arguments and so on. And so what we want to do is we can, even at this point, use our executable to give us some guidance on how we're going to triage our switches. And so, for instance, what we can do here is we can pull one of our samples here. How about if we do the left up, so /left/up, and then from the table that we built, we said that we want that value to be red. Well, you'll see there that we are going to ultimately have an argument count of 4. And you can see then what those 4 arguments would be, the 2 switches, as well as the value that we want to then assign to that location in the grid. So let's see how we can actually utilize this. So I said earlier that you want to have a copy of the help STIPS file. You don't necessarily have to have it. I borrowed the one from the fundamentals demo. Just makes your life a little easier. We want to go ahead and add the help to our list of function prototypes. In this particular example, we don't have any until now. And then go ahead and use this template then, if you would, to go ahead and add the stubbed in function. And of course, make a quick change here to emphasize that this is going to be our QN switches executable. And the idea here is, I'm going to shorten this up a little bit because this is not going to be quite as long as some of the other ones. But fundamentally here, that /h is going to call the help. Now, continuing on with the table that we had, we said that we wanted to also handle /?, which is going to call the help. And one of the things that would be nice to do here is at the end of each one of these is to provide the argument count. Once again, just helps us in triaging our switches. So if we do this, we would have an argc equal to 2, because 1 for the executable and 1 for the switch. Likewise, for /?, this is also going to be argc equal to 2. But then if we continue on, we want to look at the other examples that we're interested in, particularly the idea of the left up and then the color. And we'll put a little bit something more useful here. Changes the left up element. And notice here that our argument count is now going to be equal to 4. Now, the pattern is going to be roughly the same for each one of the additional switches that we have. It's just simply going to change what the tier 1 and tier 2 switches look like. So we said that left down was going to be green. At this point, we can do a little bit of cleanup on our help. Didn't give us quite enough room. And then we want to change the left down element, but still the argument count is 4. Likewise, we can now do right up. And we said we want to change that one to blue. And then lastly, the right down. And if we follow along with the example that we did, we want to make that one yellow. point is let's see if we can now convert this into code. And so there's a couple of different ways that we can structure our if statement. You can do this as a flat structure. You can do this as nested. You can do it as a hybrid. And so my goal here is not necessarily to do the most efficient, but maybe come up with an example that will help you understand better how to triage your switches. And so the first thing that you want to note is the count, or the argument count, for the number of switches that are passed to your executable. And if you're careful here, you notice that in no scenario can you end up with less than 2 switches. And so right off the bat, what we can probably do is we can simply check to see if our argument count is less than or equal to 2, in which case we simply want to make a call for help. And specifically, we want to make an implicit call for help, meaning that the user didn't know that they were calling help, but basically they just didn't provide us with enough information for your executable to do anything useful. At this point now, what we can do is we can assume that we have at least 2 arguments. We don't know how many we have, or we haven't yet triaged how many we have. But in order for us to get to this else if branch, we simply know then that we at least have 2 arguments, which means that we can then leverage using string compare I, the value in our argv square brackets 1. Now keep in mind, argv square brackets 1, if you recall from the command line, was the argument that came right after the name of the executable. And so what we'd like to do is we'd like to check to see if that matches our /h. And if it does, in other words, if string compare I returns 0, then what we do now is we simply make an explicit call for help. And why explicit? Well, that just simply means that the user intentionally asks for help from your application. It doesn't mean that you've called the function any differently or anything like that. It's just how we're triaging these switches. And then we can follow this up optionally, of course, with the argv square brackets 1, and we compare this now to /?, but fundamentally the results are the same. We want to call our help. And once again, we want to note here that this is an explicit call for help. Now, you can definitely combine these 2 statements just simply by using an or. That's perfectly fine. Once again, I'm trying to keep this fairly straightforward. And now what we want to do is we want to look at the remaining 4 options that we want to handle explicitly. And once again, there's a variety of ways that you can go about doing this, and each situation will be slightly different. I could have continued on with this flat structure, if you would. In other words, just continue with a series of else ifs. But what I'd like to do is I'd like to change this up ever so slightly, and I want to focus now on my argument count. In this case, my argument count of 4 is going to be required for all of the remaining explicit options. And so what I can do now is I can simply have an else if that looks solely at the argument count. And so if argc is equal to 4, we know that we are potentially dealing with one of the remaining 4 scenarios. And then we can follow up with an else. And if somehow we manage to get down to the else, we once again make an implicit call for help. Now, if you go back to the scenario where we have our argument count equal to 4, then what we can do is we can start looking at what is our argv square brackets 2, or our tier 2 option, as well as the remaining tier 1 options. And we can also at least assume that the user provided something for the color. Now, once again, we're not going to get into any validation of the color in this particular example. We're just going to assume that there was some piece of information that was passed after the combination of the tier 1 and tier 2 switches. But what we can do now, and once again, there's a couple of different ways that we can do it, is we can focus on using string compare I to look at our argv square brackets 1. And if it matches our left, then we know that we at least want to deal with the left side of our grid. And we can follow this up with an else if string compare I, argv square brackets 1, and then once again follow it up by looking at the right side of the grid. And then under the else means that the user provided something for our tier 1 that we did not understand. So put another way, something other than /left/right, or technically /h and /? was provided. Well, just like in the earlier examples, we would like to make an implicit call for help. Now, let's look at our argv square brackets 2, or the tier 2 switch. And we once again can write an if statement. We'll look at using our string compare I now at our argv square brackets 2, and we'll simply check to see if it matches up. And if it does, what we can do here is we will note that this is now left up. And then an else if, which we'll look at using our string compare I, argv square brackets 2, and the /down option. And if that's equal to 0, then essentially this corresponds to our left down. And then once again, under the else, it just simply means that our user did not provide a valid tier 2 switch, in which case we want to once again make an implicit call for help. Now, at this point, we could type the same nested if statement inside of our right branch for our tier 1 switch triaging. But instead, what we can do is a little bit of creative copy and pasting. And the only thing that we really have to change is our comments. And so you'll note that effectively what we've done is we've now handled right up and right down. Now, at this point, we will simply assume then that the user provided something useful to us for our fourth argument, or argv square brackets 4. And so rather naively, we're just going to skip the validation. And instead, what we're going to do is we're just going to provide, for completeness sake, in this example, a print statement. And the print statement will be something along the lines of changing, in this case, the left up quadrant to, and I'm going to just include a %s here to be able to provide back to the user whatever they included in their argv square brackets 3. And once again, a little bit of judicious use of copying and pasting, where we now change this to left down, changing the right up, and changing the right down quadrant. Now, hopefully you can see how we've effectively handled either the 5 or the explicit cases in this scenario. We've explicitly defined 6, where we've separated our /h and our /? into 2 different possibilities. But fundamentally, though, we have handled all of our explicit switch combinations that we expect the user to provide. And at this point, everything that does not fall into those categories then gets a call to help. As I said earlier, you could write this logic any number of ways, but once again, I'd like for us to see a little bit of variety. I'm going to go ahead and build this. And now it's time for us to see our executable in action. And the first thing that we want to do is we simply want to provide the executable with no switches. And you can see that sure enough, it's actually making a call to help, telling our user how to use our executable. Likewise, if we put in /?, we get the help, and /h, we get the question mark, we get the help. And also if we put in something or nonsense, well, there you go. And you're going to get the help. Now, let's go through some of the combinations that we want to address, particularly the left. And if you notice, if we only provide it with /left, we once again get the help because we did not provide it with a complete set of arguments. And if we do /left/up, once again, the help. And so we have to have that additional color. And so now we see that it says changing the left up quadrant to red. And by the way, before you think that there's any sort of magic associated with the examples and the help and what I provide to the command line, there isn't, because how about if we then change this to another value? And so you can see here that I can see it changing the left up quadrant to gray. Likewise, we do left down, and we're going to do green. We go back now and we change it to right up, and we'll do blue, and then right down, and then yellow. Once again, there's no magic in the examples that I've given us as far as the color. And then also note here, if you have some sort of misspelling in your switch, even though you provide the correct number of arguments, you should in fact still get the help, because fundamentally you've misspelled your tier 2 switch. In this case, the down was misspelled. So hopefully this example provides you with some nice closure to the quiz question. As always, if you have any questions, comments, or concerns, don't hesitate to email me, and thank you for watching.